Hi, Michael again, and today we're going to have a look at a PowerTech 12 volt 1500 watt modified sine wave power inverter. Basically it's a 12 volt to 240 volt inverter. It allows you to have AC power out at 240 volts, and it's a modified sine wave. It's not a pure sine wave output, so a bit choppy if you want to use it on, say, PCs or laptops that are a bit sensitive to the waveform that comes in on the AC side of things. Not advisable, but okay for other devices like power drills or angle grinders and stuff like that. Haven't had any problems with it doing the angle grinders, which draw a lot of current, but only on the initial startup. It has a 3,500 watt surge capacity, which is good for up to I think about 5 seconds of surge, and then it will cut out if you try and draw too much after that. So the fault with this unit that I've got today, I've just hooked it up to the bench power supply, but it just trips out. So I suspect that it could be a faulty Mosfet circuit. We won't know until we've pulled it apart. And that is running on the laboratory bench power supply, which is capable of delivering up to 12 amps. This thing will draw a lot more than 12 amps, but it shouldn't draw much more than, say, 5 amps if it's got no load on it. So I could try it on a battery and see if that helps. Actually, let me get a battery and we'll test it on a battery. Okay, so I've got my trusty battery here. Hopefully my voltage, my surface voltage on the battery is good. We're at 12.93 surface voltage. So that should be fine. Let's test that inverter. Negative and positive. Might help if I turn it on. Yeah, turn it on. Bit of capacitance in there. Yeah, it's still faulting out. Not charged, not running. So we've got a fault light come on. I wonder if there's power actually coming out of it. Let me check. Just check AC voltages. Can you see that? AC voltage. Let's test this again. Yeah, it's jumping, it's trying, but it's not working. It's getting about 20 or 30 volts AC out of there. About 34 AC. 40. It's just not happy. Okay, well, let's open it up and see what we can find. And actually, before I open it up, just so you do know that the battery is good, I will put the battery in DC volts and I'll turn the inverter on and just make sure we've got sufficient battery. Yeah, 12 volts, 11. That battery seems to be okay. I probably could do with a charge, but the battery's not dying as such. It's still coming back up, so no, there's another fault there. Alright, so there's 4 screws either side. 2 there, 2 there, 2 there and 2 there. I have removed those screws. I have also, there's a holding plate that holds the Mosfets up against the heatsink. I've removed that as well. As you can see, this one hasn't been removed. This one has. So I'm just trying to make this video as short as possible because I don't want to have it go on for too long. Also, when you do, before you open the item you're working on, it's a good idea just to make sure that if you put the two wires together, bridge the two wires together, that it discharges the big internal capacitors. Because you don't want to be working on that when the capacitors are charged up. But that was alright, they were already discharged, so I checked that. So what we got here, we've got 4 Mosfets. They are a G20N50C, and we have another 4 Mosfets over here, which I haven't taken the plate off to look, but they will be the same part number. Okay, so I've got to remove all these screws that hold these other brackets in place to allow me to get the circuit board out. So if we remove these, they're holding all these transistors down against the circuit, against the heatsink. And this is the easiest way to get this out, this board. It slides in a channel, so either one way or the other, which would be the easiest way. Looks like I have to take both ends off anyway. Let me pause this and I'll come back. Okay, so we've got both those ends off now. This end here is got a couple of headers that can pull out there, which how's that going to help us? It's not really going to help us anyway. So we'll look at this other end. Okay. I should be able to slide that out. We want to go this way. Oh, I've got to take this earth wire off. Okay, so we've got the earth wire off. They've put this goop here to stop the circuit board from moving. Is it going to move? Ah, yes. Yes. Good. So we can get that out. We'll remove those Mosfets and test them out of circuit. I'll tell you, that soldering looks very good. How you doing? Right. So let's remove those Mosfets. Okay. The desoldering iron should be hot enough now. Let's start with this one here. Where is it? Maybe it needs to be a bit hotter. Okay, try again. Just going to flow a bit of leaded solder on there, just to help. We should be able to remove that solder. Okay, that's one removed. Let's see what the multimeter says. in diode mode. You see that all right? Okay, so we've got the Mosfet out of the circuit board. To test this Mosfet the quick and dirty way, make sure, see if it's working or not, we can open and close the drain and the source via the gate, just with the multimeter in diode mode, and that will tell us if the Mosfet is working or not. So I've pulled this out and we'll test it and see if we have a working Mosfet. I'm going to have to do all of the others. I'll pull them all out of circuit because I can't test them in circuit. So we want to put the negative lead of the multimeter in diode mode. And I put the negative lead on the source. I put the positive on the drain. No, I can't see the multimeter, sorry about that. And we have an overload or open circuit. And if we just touch the gate for a brief period of time, we should then find that the drain has a closed circuit or thereabouts, which we do. We have 0.349 forward in voltage. And to close the gate again, we just need to short out all these pins, and we can recheck, and we should have open circuit, which we do. So that's just a quick and dirty way to make sure that the Mosfet is actually working. Put it on there again, and the source to drain is closed. Short that out, and the source to drain is now open. So that Mosfet seems to be working. I'll pull all the other ones out and I'll do the same check. So we've pulled the Mosfets out of the inverter, all 8 of them, and we're going to test the Mosfets to see if they turn on and off across the source to the drain using the quick and dirty way, and that will give us a bit of an idea if we've got any dead Mosfets. So make sure you can see the multimeter there, and we'll go across on this one. That one we've got open across the gate, and it's now closed. So that one works. Let's just short those pins out, confirm that it goes back. Yep. Next one, same. We've got a dead short, so we'll just short that pin out, and we still got a dead short. So this one is obviously a dead Mosfet, so we'll put him aside, put him over there. Test this one. Open, close. Short those pins out. Open, close. So that one's okay. Test this one. We've got a dead short on that one. Still got a dead short, even if we short the pins out. Still got a dead short, so that one is dead. Let's try this one. Open, close. Short those out. Open, close. So that one's a goodie. Try this one. Open, close. That one's a goodie. Open, close. Now we're only getting 0.3 of a volt when it's not exactly fully closing on the gate. Open, close. 0.273 volts we're getting across there in diode mode. That's because our multimeter's only putting out about 2.5 volts on the probes in diode mode, and the gate on these doesn't fully close the source and drain until it gets to around 5 volts. But I can inject 5 volts into it and show you how it fully closes these. So that one's a good one. Open, close, it's a good one. And the last one, open, open, open. So this one's dead, it's not even closing. All right, so the other thing too, you've got to be aware that most multimeters, or I should say, I'll correct myself, some multimeters not necessarily will give you the high enough voltage to close the gate. I'll give you an example. I've got another one here. If I try with this one, put that into diode mode. And if we go across the source and drain, put the negative probe on the source, positive on the drain, you can see that's open. Put it across to the gate, put it back to the drain, and it's still open. So you might think, oh, that's faulty, that Mosfet is faulty, but it's not. It's actually the fact that this multimeter doesn't put out enough voltages on the gate to close it. This only puts out about 1.5 volts on the diode mode. Another multimeter here. This one here, we'll put it into diode mode. And we'll show you the same thing. So in diode mode, whoops, shush. Okay. Yes, in diode mode, where are we? Diode mode. Rightio. So that says it's open, go across, and it still says it's open. So same thing with this multimeter, it doesn't put out enough voltages. So if you have that problem, quick and dirty way might not work. I've drawn a bit of a diagram here, what you can do to test a Mosfet with a multimeter that doesn't give you enough voltage, forward voltage out of the diode circuit. So basically you've got your source pin here to your negative on a multimeter in ohms or continuity, and your positive to the drain from the multimeter, and then you have 6 volt supply. In this case we've got a 6 volt supply. The actual Mosfets that we're playing with here have a gate to source voltage of up to plus or minus 30 volts. This is absolute maximum ratings though. So 6 volts, well 5 volts is enough to trigger it to a full close. So I'm just going 6 volts. And so basically you momentary trigger 6 volts across the source from the negative to supply of voltage and the positive supply to the gate. Momentary close that will cause the multimeter to go into a closed, closed circuit, or connectivity will be closed, and so voltage will show that it's a dead short. And then to open the gate, or to open the drain and source, I should say, you short out the gate to the drain. In this case, we've got another momentary switch, and that will then cause the drain to source to go into open circuit. So I'll show you that with this multimeter that we know didn't work. Okay, we're back again. Sorry about that, phone got interrupted and had to take a phone call. So I've set up the Mosfet in a practical sense so I can show you how to test it. We've got 6 volts on this multimeter here. which is across this terminal and this terminal here, which is not bonded to anything. This multimeter here is going to be measuring continuity, and it will tell us whether we've got a dead short on an open circuit across the drain and source, and we can trigger the drain and source to be closed or open via the gate, and we will apply 6 volts onto the gate with this wire here, and we'll show you how that works. I also will add that this pin here, at the moment the drain source is closed, this pin here is also the backplane pin. So for testing purposes, I will put the multimeter on the back here. So you can see that is closed. If I was to short out this pin to that pin, as in short here across those two, the drain to source opens, and if I apply 6 volts across the gate, the drain to source now is closed. So that shows you that MOSFET is working as it should be. So open, close, open, close, open, close. There you go. Alright, so now I've set up the same situation, the same circuit with the dead one. We've got 3 dead ones here actually, and I'll just show you what a dead MOSFET will do in this situation. So across there again, if we trigger the gate, the drain source closes, but as soon as we remove the gate, the drain source opens. So in fact, that one is trying to work, but it's not working 100%, because you should have the drain source stay closed when you remove the voltage off the gate. It's not until the gate voltage drops to equal the source or below the source voltage that the drain source will open. So that one is dead. And if I grab another one of the dead ones, and we'll do the same test, we can see it's got a closed drain to source. Even if we were to short out the drain to gate, it's still closed. And if we apply voltage to the gate, it's still closed. So that is a dead MOSFET as well. So I'm going to need to order in some new MOSFETs for this power inverter. Now I've got 5 good ones and 3 bad ones, but I'm going to order in 8 good ones, so they're all of equal value, and we'll take it from there. So this will be part 1 of this power inverter repair, and we'll see you on the next one. Thanks for watching, and please hit the like and subscribe button, and we'll see you on the next one. Bye.